let's go to the bottom and let's talk about functions on a little bit higher level. Okay, I want you to draw me 3 x and y axes. Just sketch them. You don't have to use a ruler. I just need 3 x and y axes, and you need a colored pencil. Just like this. Okay, on this one, we're going to draw a line something like that. Okay, on this one, we're going to draw like an S. And on this one, we're going to draw like a V, kind of like that. Now, what did we say makes a set of numbers, and each one of these is a relation? Each of the one is a relation. It's a set of infinite ordered pairs. It's not finite. So if I ask you its domain and range, you would have to be able to say it a little more in this category up here with this inequality, because it's a lot of them. It's not just 1 or 2 or 3 or 5 or whatever. It's infinite. But what's going to make it a function? Now, Jude said a while ago, the x's cannot repeat. So we need to know if it's a function. Now, let's just take, and this morning I went over there, but because I'm doing it for the people on the camera, I'm going to stay right here. And let's just talk about, if I go to this graph right here, how many points are on a line? Infinite. I mean, there's infinite points, right? Could you name some of them if they were labeled? I mean, I know that one is 0 something, like 0, 2, right? This one might be 1, 5, and this one might be 2, 7 or something. Now, can you look at this and know whether there will be any x's that would have another y? Because really that's what happens. Like 2 might be paired with 7, but 2 might also be paired with 3, right? So when I look at this and I go over here to my positive numbers, if I go to 2, is there only one y with that x? Do you see another number? I think when we see the no, it'll make a little bit of sense. But now if I go out to 100, you know, this graph is continuing all the way up. When I go out to 100, is there only going to be one y to that x? If I go to 0, 0 has that number, say it's 2. Go over here, say that's -2, 1 point. Go to -3, there it is. There's your y that goes with it. Might be -1, might be -3, -1 or something like that. So yes, this one is a function. Now look at this one. Let's take x equals 0. Now, if you drew it kind of like mine, you would agree that 0, 0 is on this graph, somewhere in that vicinity, right? But what about that point right there? Tell me about that ordered pair right there. You might not know what the y is, but you know what the x is. What's the x of that ordered pair? 0. So it might be 0, 7. Uh-oh, I've got 0, 0 in blue, and I've got 0, 7 in blue. Is that repeating x's? Do they have the same x? Is it a function? No. It's got 3 of them. You've got 0 something up here, you got 0, 0 right here, and you got 0, negative something here. So, you know, why is it not a function? Because there's a classic one, but there's a lot of them. I could go over here at -1. Look, there's a y there, there's a y there, and there's a y down there on the graph. So you don't have to have the list of numbers to be able to tell it. It has a name to it in just a minute. What about this one? Does it look like it is? Look like it's a function? Because you go to like 2, it's got a y. I go to 3, it's got a y. It's got one y. So this one is no, and this one is yes. And so see if you remember that. It's called the vertical line test. Now, it's hard for me to write out how you describe it. You could Google it, I guess, and it would say what you're doing. But what you're visually doing is picturing a vertical line, and sometimes I take like a ruler or a pencil, or I have a little pointer up there that I use. So when I come across this one, if you can see it, when I come across this one, everywhere I stop, we're only checking x's. So I stop at that x, -3. Does it only have one y? Yes. If I stop at this x, -1, does it only have one y? So it's called vertical line test. So you're visually thinking about looking at points, looking at the x's, and does every x only have one y? And see here, when I stop, like here, that might be -1, and it's got 3 different y's. So it would be like -1 something, -1 something, -1 something, not a function. So you can look at a graph, and we use that characteristic all the time before we ever start, and we say, is this a function? And we do, your graphing calculator is a function graphing calculator. It is very difficult to graph things that are not. I drew a circle on the board. Would a circle ever be a function? When you pass a vertical line test over it, would it ever, are you only going to touch one point? No. A circle is never a function, and you can draw it on your calculator, but it's really hard to do. Your calculator likes to do functions. It doesn't like to do non-functions, and I usually don't teach how to do that because it's just too much work to draw that. So your calculator loves to draw functions. Okay, let's see if we can do one of them, and we should be good. And again, I don't expect you to be on this one go, oh, yay, I get it. You may, and then one of them may catch you up. Some of them have got little tricks to them. We call this problem number 1. And there's 3 things you will do for me on classwork. You will tell me the domain. You will tell me the range. And go and write the whole word right now so that you'll remember. And then we want to know if it's a function or not. That's the part I added, because you asked me about the instructions. Somebody, McKinley or somebody asked me, and I said, I'm going to add a thing to it. I think on it just said find the domain and range. Okay, here's my question. Is it a function?
Yeah.
Think so?
As long as the lines at the end aren't straight.
As long as you, with a vertical line test, if I go up and down, does -1 only have one y? Now, what is this? -4, what is that? A -2? -2 doesn't have a point. Notice that it's open, but that's kind of the ending point there. But see, -1.9 does, and it only has 1. And then 0 has 1, and let's see, what is this? Something like maybe 1.2 or something, or 1.5. It's got 1, and then 2 at -2, even though it's an open dot, it's still every point, do the vertical line test, there's only 1 point. So yes, it is a function. Okay, let's do its domain and range. Now here's the problem. You can't name every x, can you? Because you've got, okay, I could put 0, -2. That's an ordered pair on it, right? I could put -1, and that looks like that's maybe -3.7 or something. I could estimate it. But then you've got all these little in between. What about -1.1? And what about -1.17? I mean, there's infinite points on this graph. Even though it's a one end to the other and it has endpoints, there's still infinite points on it. I cannot name every x. Like in your classwork, you would look at the dot and you would say, oh, -1 has this point or whatever. So here's how we do it. We're going to use, and I couldn't find a red color pencil, so besides domain, I'm going to put a red dot. And besides my range, I'm going to put a blue dot. I don't care what colors you use. It just, if you want yours to look like mine, it just makes it really nice. Okay, here's how it works. Okay, we're going to do domain down here. And then we'll write right over here what it is as an inequality. Okay, I need to know what x's have y's. Okay. Even if the x's, if it wasn't a function and it had more than 1, I still need to know what the y's are. Now, I need to know my endpoints first. So I think you would agree from the left to the right that -2 is my far point, and I'm going to bring that point straight down and put an open dot right there underneath that -2. And then I go to the far right, and below the 2, I'm going to put an open dot, because we agree that 2 doesn't have a y and -2 doesn't have a y. Now, do all those points between -2 and +2 have a y? Does -1.5 have a y value? Yes, you could estimate it like -3 point something. Got it. So, do you agree with me that every point between those two have a y? Now, tell me what that is as an inequality. Look at page 10. What is that? Well, domain is x's. So we put our x in the middle. It's a between statement. Do we agree it's between? And what is it between? What's the smallest one? -2. We always put less thans because you put the smallest one on the left. Yes, I know you can write them with greater thans, but it's not mathematically correct. So just because you can write it that way doesn't mean it works. And then less than, what was the biggest one? 2? Now, are either one of these equal? No. Every x between -2 and +2, not including those two, have a y value. Okay? Infinite answers. Let's do the range. Turn your notebook this way. Okay. With this up at the top. And now, and this is where you kind of got to think outside the box. It's just exactly like we just did. And we're going to visualize this graph now from left to right. And I'm going to do it in blue over here, range. Okay. Now, do you agree with the y-axis now? This is my y-axis. I want to know what y values have x's. So, I'm going to go all the way down to the far left, and to me on the y-axis, it looks like the far left is that point right there. Do y'all agree? Okay, now is that a solid dot? Do you see a little open dot there? Is there an open dot at that point? There's not a hole there or anything. So that's a solid dot. So we're going to come down and put a solid dot right underneath. What is that? -4? Okay. Now everybody gets a little freaked out about these dots right here. But, well, let's do the upper end first. So I go up here. Now see, we're looking at the y-axis. This is 0, y equals 0. And so this is my 0. I'm going to put a solid dot because it's that point right there. It's the farthest to the right. I've seen some teachers teach it where you put your, like take 2 pieces of paper and you like cover it up and you just tell me, you know, what's the left point you see and what's the right point you see. Now, does every point in between those have some values? Does every point have one? Now, people get a little freaky about this one, but look, this point doesn't have it, and this point doesn't have it, but this one does. See, that point right there is, what was it, 0, -2? So -2 has an x value. So we're going to make it solid. Now, I'm actually going to write it on here. That's what I did it with second block because we didn't, well, I don't know if we had time to put it back over here, but I'm going to write it here because when you do it sideways, you may not can see it. Do you agree it's a between statement? Mm-hmm. What's this number? -4. What's this number? 4. No, it's not. Look at the y-axis. Look at your y-axis. What is the y right there?
0.
Look up there, right here. That y right there is 0. See? 0, -1, -2, -3, -4. And it's everything between. So we'll put, now we don't put an x there because these are our y's, right? We put less thans. Are either one of these solid dots? Both of them are. So we'll turn it back. And my range is -4 is less than or equal to y is less than or equal to 0.